Good morning, students. So in this video, I am going to explain about the general operation amplifier stages or operation amplifier block diagram. So the commercial integrated circuits operation amplifier usually consisting of four cascaded blocks. So the important stages of operation amplifier IC741 is input stage and intermediate stage and output stage. So these are important stage in the general operation amplifier stages. So these are the main integrated circuit diagram for the IC LM741. So this circuit comprising of the four stages: input stage and intermediate stage and buffer level and shifting stage and output stage. So we will discuss and detail on each and every stage. So general description of the IC LM741 circuit diagram is generally the LM74 IC consisting of 24 transistors and few resistors, only one capacitors, then two power supplies and short circuit protection. The input stage. The input stage provides high impedance to prevent the loading on the high gain stage. So it requires two input terminals. It also requires two low output impedance. So all such requirements are achieved by the using the dual input or balanced output differential amplifier as an input stage. The function of the differential amplifier used to amplify the difference between the two input signals. Generally the differential amplifier has a high input impedance. The stage provides most of the voltage gain amplifier. So the Q and Q4 is a differential version of a CC and CB configuration. The current source Q5 Q7 is active load input stage. The only to provides high resistance load, also converts the signal from the differential to single-ended form with low loss in gain and common mode rejection. Next one is the intermediate stage. The output of the input stage drives the next stage, which is intermediate stage. So this is another differential amplifier with dual input and unbalanced and single-ended output. The overall gain requirement of operation amplifier is very high. The input stage alone cannot provide such a high gain. The main function of the intermediate stage is to provide additional voltage gain required. Practically, the intermediate stage is not a single stage amplifier but the chain of the cascade amplifiers called a multi-stage amplifier. The levels, this is the intermediate stage. The intermediate stage is composed of the Q16, Q17, Q13B transistor. This is a common character configuration. And Q17 is a common input configuration. It provides high voltage gain because of the active load of Q13B. So the capacitor CC introduces a Miller compensation to ensure that operation amplifier has high unit gain frequency. Last one is the output stage. The level shifting stage. The level shifting stage is the output amplifies the DC signals also. So the stage by stage DC level increased by ground level potential. So the high DC level potential that may drive transistor in saturation. The level shifter stage brings the DC level down to the ground potential. So the buffer generally used as the emitter follower as input impedance very high. This prevents the loading of the high gain stage. The last one is output stage. The output stage is efficient circuit as a class AB output stage. This is called as a push-pull amplifier. Basic requirements for the output stage is the large output swing capability and large output current swing capability and low output impedance and low quotient power distribution, short circuit protection. These requirements generally can be fulfilled by the push-pull amplifier in class AB. So satisfies all above the requirements. So class B push-pull amplifier basically emitter follow with the complement transistor. So this diagram, the circuit B is the emitter follower, class A output stage is the push-pull amplifier. So this satisfies above the requirements of output stage. The one of the major limitation circuit is that the output voltage remains 0 as long as Vin is less than VE. So this introduces a crossover distortion in the output. This is also known as voltage transfer cancels out the output. Such a crossover distortion can be avoided by applying the bias voltage greater than 2 VB between the two bases. So this ensured for flow the small current in the transistor even in the constant state. The reducer crossover distortion can be implemented by supplying the constant DC voltage at the base terminals. So to stabilize the quotient base current, the small resistance R is used between the emitter and Q1 output. That's a resistance that provides a limited short circuit protection. So the Q and QB provides a voltage drop which equals to the sum and tan of the voltages and Q and QB. This circuit is called a closed output stage. So the biasing circuit uses the Whittler current circuit. The Whittler current provides the biasing current in the order of microohms. So the double collector transistor similar to the two output current mirror Q13B. So provides the biasing current for the intermediate stage and Q13A output stage. The transistor Q5 and Q6 and Q7 composed of the current source to be active load for the input stage. So this is called as ideal operation amplifier symbol. So now we are discussing about the characteristics of ideal operation amplifier. So generally the ideal operation amplifier has the following characteristics. The input impedance is infinite. The voltage gain is infinite. The CMR, common mode rejection value, is infinite. The bandwidth also infinite. So finally the output resistance is 0. So no input currents because of the input resistance infinity. So there is no input currents flow through the base terminals. So the no difference voltage between the inverting and non-inverting terminals. So this is an equivalent circuit for the ideal operation amplifier. Because of the I1 current is the input current. So the I1, I2 is 0 because the input impedance is infinity. So this ensures there is no current flowing through the input terminals. So this is all about the block diagram of operation amplifier LM741 and the general stages of the operation amplifier and ideal operation. So this is a equivalent circuit of ideal operation amplifier. So here the no current flowing through the input terminal because of high input impedance at input terminals. So the equivalence in ideal operation have here infinite CMMR and 0 output impedance. So I1 equal to 0, I2 equal to 0 because of high input impedance at the input terminal. So this is equivalent circuit diagram for ideal operation amplifier. So next one is the inverting configuration. So the circuit shows the inverting amplifier configuration. So this is an inverting closed loop configuration and virtual ground. So this circuit mostly used of all the operation amplifier circuit. It is also termed as a phase shifting circuit. So the otherwise called as a phase shifting circuit. The output voltage V0 is feedback into inverting input terminal through the feedback resistor, and R1 network where RF is the feedback resistor input signal and Vi is applied to the inverting input terminal through input resistor R1, and non-inverting input terminal operation amplifier is virtually grounded. So the negative sign indicates the phase shift of 180 degree between and input voltage and output voltage. Since inverting input terminal is virtual ground, the effective impedance is R1. Okay, this is all about inverting configuration. So the output we will get is 180 degree phase shift. The next configuration is the non-inverting configuration. So if the signal is applied to the non-inverting input terminal, a feedback is given as and shown in figure. The circuit amplifies without inverting the input signal. Such a circuit is called as a non-inverting amplifier. It may be noted that it also negative feedback system as output is feedback to inverting input terminal. As the differential voltage Vd is at input terminal of operation amplifier 0, at voltage node A at the V1 I same as the input voltage applied to the non-inverting input terminal through RF and R1 forms a potential divider. So the gain can be adjusted to unity by proper selection of resistor and RF R1 compared to the inverting amplifier. The the input resistance of the non-inverting amplifier is extremely large, that means infinity, as operation amplifier draws a negligible current from the signal. So that means the input impedance is equal to infinity. So it forms the series and negative feedback from between the input and output. So this is all about the non-inverting configuration. So this is a final output equation for non-inverting configuration. V0 equal to V1 plus V1 divided by R1 to R2, and V1 into 1 plus R2 by R1 is the final output of the non-inverting configuration. So next one is